I wanted to give you an explanation of Essential Question 2, version 8 during the summer of 2011. This is another one of those time value money calculations. So let's start off knowing that we're actually looking for the present worth of this thing. And what I want to point out is that this one's tricky in the sense that it's all in the negative domain, which might be unusual for what you're looking for. It's got a segment over here that looks like a constant series, another segment over here that looks like a linear gradient series, and another segment over here that looks like a linear gradient series. So this one actually is going to have a couple of parts. The first thing you should spot is that the linear gradient series here does not actually start at 0, so you have to think of it as being supported by a constant series. So you think you should see a constant series that goes -3, -3, -3, and keeps on doing that from period 0 all the way through period 7 right here. And then that linear gradient series sits on top of it. And then what you're going to have is this other linear gradient series, but it also doesn't start at 0. And so what you have to think of is this constant series that goes -6, -6, -6, and then this linear gradient jumps off from it. So let's start with this long constant series we have right here. And so you're looking for something that is -3 high, looking for P, giving you know A, where the interest rate is, and there are 1, 2, 3, 4, 5, 6, 7, 8 of those. We know that it's going to be time shifted a little bit. And if you see it starts at time period 0, that means where it dumps all its values time period -1. And so what you're looking at here is 8 plus -1 equals 7, and that tells you that you're actually spotting the last value in time period 7. So it's great. We got this constant series. Now let's add in the linear gradient component. So we're looking at something that actually goes down by 1 every single time here. So we're going to have this -1. And we'll be looking for P, given that you know G, whatever the interest rate is. And the end's going to be 1, 2, 3, 4, 5, plus 1 for the pot is 6. Let's go ahead, and we know this one has to be time shifted. And so we're looking at something which appears to dump its value all in time period 1. So we'll go ahead and put a 1 right there. And so what you're looking at here is 6 plus 1 is 7. That's the last time period it's there, so that's like the double check that you're supposed to be seeing. So now let's go ahead and get this part right here that has to do with this constant series and this linear gradient series right here. And I'm just going to quickly erase a chunk of this so that we've got some space in order to put that chunk in. So this is just adding to what's going on over there. And so the constant series should be something which is -6 tall, looking for P, given that we know A. There's the interest rate. And the n on it should be 1, 2, 3. We still need to time shift this, 1 plus I. And this appears to dump all its value into time period 7. If you add the 7 and the 3 together, you should get the last time period. You're going to see that element in the constant series, which is 10. And then what we're going to have is this linear gradient chunk. You see that each time it goes up by 2. So we're looking for P, giving you know G. Here's the I. And we're doing it once, twice, third time for the pot. And then all we have to do after that is do a little time shifting. And this looks like it dumps everything into time period 7 again. So it all seems to key off time period 7. Anyway, this should show you the present worth of this unusual cash flow sequence. Essential question number 2, version 8 during the summer of 2011.